The last type of transformation we'll be covering is dilations. And dilations are sometimes known as stretches or shrinks because you're going to be multiplying or dividing the values to make the function look bigger or smaller in different dimensions. So you can have dilations in the x direction. And so what that would look like if we take, say, the absolute value of x, if you are stretching it in the x direction, you will end up with a wider function. And then if you are stretching it in the x direction, you would end up with a taller function. There is a fair amount of overlap, especially in the simpler types of functions, where you can write the same dilation as a vertical stretch and a horizontal shrink, or vice versa. So often there's going to be more than one correct answer. So let's look at vertical stretches and shrinks first. So if you have a function f of x, what a dilation vertically would look like is that every y value is multiplied or divided by the same thing. So if we wanted to do a dilation of a factor of 2, you would take each y value and multiply it by 2. So the only places it'll stay the same is at 0. And so the big change ends up being that the graph will look stretched in the vertical direction, so it'll look a lot taller. The way this looks like in an equation is that to get your values of g of x, you're going to take your original values of f of x and multiply them by whatever your scale factor is. So if a is greater than 1, you're going to be stretching, and that'll make your graph look taller. If a is less than 1, that means you're going to be multiplying by a fraction, and so that's going to be a shrink, and we'll make it shorter. So we're only talking here about positive values of a, because if a is a negative number, then you're combining a dilation with also a reflection. So for horizontal dilations, you can think about them in a really similar way. So instead of talking about multiplying y values by some factor, you could say for this same y value, we're going to multiply the x value by that factor. So if I'm looking at this particular y value, if I am doing a horizontal stretch, then the original x value is going to be multiplied by, let's just say 2 in this case. Same for like this y value. So its original x value was here. We're going to double that, and so its new x value would be way over here. So these functions end up looking a lot broader or wider, or conversely, narrower. So when you're writing the equation, these are going to end up looking like f of x divided by a. So when a is greater than 1, this is still going to be a stretch. And a stretch horizontally is going to make it look wider. If a is less than 1, which means if a is a fraction, it's going to be a shrink, which means the graph will look narrower. And so the reason why we multiply by a in a vertical transformation and divide by a in a horizontal transformation is the same as we were talking about in the translations, where when we're changing the input, we end up doing the inverse of the operation. And so if I wanted to get the same y value from like f of 2, that same y value now happens at g of 4. So to get the same output, I would be dividing 4 divided by 2, which would get me back to f of 2 to get that same y value.